Alright guys, so today we're starting on Chapter 4, Section 1. Now recall the last time we did Chapter 4, Section 3 or Section 8. And now we're actually going to go to the beginning of that chapter, and there's a reason for it, okay? Throughout your math career so far, you've used angles, right? Especially in geometry. And you use protractors to measure angles, and the units for measuring angles were degrees, correct? Now here's my question to you. Sometimes when you're using those protractors, could you actually every time give me an exact measure of an angle, like, oh, this is exactly this? Sometimes you were like, I'm not really sure, I think it's this, I think it's that, about, right? Well, abouts are not really cool in real life because we need things to be more exact. So fortunately for us, we have another unit of measurement for angles, and that is called radians. So today you're going to learn what a radian is. Well, you kind of already know it's another unit of measurement, but I'm going to show you how they work. And we're going to make the transition from degrees to radians, okay? So before we get started, I just want you to keep an open mind. It is human behavior that you want to stay with what you know because you feel safe. So you're very comfortable with degrees, correct? And you're like, oh man, like, why are you making me do this? Okay? So just keep an open mind and expose yourself to it. Don't just right away go back to like, no, I really just want to use degrees. Because if you cannot understand radians, you will struggle for the remainder of the year because we're making that transition to it. Okay? Alright. Enough about that, so let's just go ahead and get started. We'll start with the most basic, which is that the parts of an angle. We know that an angle has two what? What are these called? Two rays that are joined by a vertex. So this is a ray over here. We have another ray over here. And they have a vertex, correct? Now, we're going to get a lot more specific. Each ray actually has a specific name, okay? This one right here is called the initial ray, or the initial side, or the initial ray. And this one is known as the terminal side, or terminal ray. Well, how is that important? Well, technically, do you guys see how I can actually switch them and be like, well, what if I want this to be the initial and when I want this one to be the terminal? That is possible to do. But when you tell me that this is the initial side, you are telling me that you're starting here and you're measuring on that direction. That's what that means. So let's call this theta. So in other words, the initial side is the beginning of the angle, and the terminal side is the ending of the angle. Cool? Alright. Now, we're actually going to be using angles, but we're going to be using them on the Cartesian plane. Do we know what the Cartesian plane is? You see that in the back? That's a Cartesian plane. The coordinate plane. Okay? So the x and y axis. We're going to be using them on the Cartesian plane. Okay? Now, why are we going to be using them in the Cartesian plane? Because I'm going to need your angles to be in standard position. And what it means to be for an angle to be in standard position is that it is on the coordinate plane and it has the vertex at the origin and it has the initial side on the positive x-axis. Okay? So label your angle using what you know. Label your initial side, label your terminal side. Tell me which direction that angle is going. Okay? Alright, do we all have this? We all know that this is the initial side. Why? Because of the definition, right? Now, here's my question to you. I asked you to tell me which direction you were going on, right? So if this is your initial side, how many of you guys went on this direction? Cool. But did anyone actually go on this direction? Can I go in that direction? Am I starting at the initial and going towards the terminal? So I can actually go in any direction. My question to you is, how in the world am I going to differentiate, like if I say go 100 degrees, if I'm rotating clockwise or counterclockwise? Okay? And the answer is the following. When you rotate counterclockwise, your angles are positive. But if you rotate clockwise, your angles are going to be negative. Okay? So even though you're starting at the x-axis, if it's positive, you're going to go counterclockwise. If it's negative, you're going to go clockwise, I'm sorry. Okay? Alright, that kind of answers that, so I'm just going to skip that. And I'm going to go straight to the examples. I want you to give me a rough estimate of where those angles are located in standard position. Okay? So go for it. Alright, check your answers with what I have. 40 degrees, you know for sure have to be located in quadrant 1, correct? So maybe something like that. Correct? And you're going in that direction. Cool? Negative 40, since I'm going on the negative, that means I'm rotating clockwise. So I'm going to be on quadrant 4. And it's going to look something like that. And I'm going on that direction. Cool? Now, 400 degrees is where you may have gotten stuck. Because you're like, well, wait a second. 400, that's more than one revolution. Well, I'm starting here. Agreed? So I'm rotating. That's 360. I need to get to 400, so I need how many more? 40. Cool. Negative 400. I'm starting here. I'm rotating. I need another 40, so I'm going to go here. Do you guys notice anything? These two look exactly the same. And these two look exactly the same. Here's my question to you. Are they the same angle? Are they? So if you think they are the same angle, raise your hand. It's okay. If you think they are not the same angle, raise your hand. Alright, so if you think it is the same angle, give me your reasoning. Yes, go ahead. Seth. So you're saying it's the same distance between the x-axis and the ray of the angle? Okay. Someone that says that it's not the same, give me your reasoning. Come on, there's a lot of you. Luis.
One's negative and plus.
Well, I was comparing like the 40 to the 400, so they're both positive.
Oh.
And then these are both negative. So like, I'm asking like, they look the same. Are they the same? What do you think, Avery? Okay, so I'm hearing the word distance, right? Is there truly a distance or is it a rotation? It's a rotation. So there is more rotation. So that means they're different. Even though they look exactly the same, they are totally different angles. Okay, so make sure you keep that in mind. Even though they look exactly the same, they have the exact initial side and the exact same terminal side, one of them has more rotation than the other, which makes them a completely different angle. Okay? Now, when that happens, this has a name. They are called coterminal angles. Coterminal angles are angles that have the same initial side and the same terminal side. Let me give you an example. I have the initial side here and I have my terminal side here. I'm going to call this angle right here theta. and I'm going to call this angle on this direction alpha. Are they coterminal angles? Why? Why are they coterminal? What's the definition of coterminal? So did they both share the same initial side? Do they both share the same coterminal side? So even though this one's positive and this one's negative, they're coterminal. Cool? Now that's one way of finding coterminal angles. The other way is what I actually showed you on the previous example. We have angle, let's call this angle theta, or I can have angle alpha. Are those coterminal? Absolutely. They're sharing the same initial side and the same terminal side. So there's two ways of finding coterminal angles. Doing a full revolution or going on the total opposite direction of them. Okay? Here's my question. If you were to add up these two angles, what would they add up to? 360 technically, but one of them is negative, right? So kind of keep that in mind. Alright, so here's what I'm going to do. I don't like the way I set up the notes, so we're going to skip around today. I want to make sure you really understand this whole coterminal stuff. So I want you to flip your notes and find where it says finding coterminal angles. Okay? Recall, coterminal angles have the same initial and terminal sides. And I want you to go down here because we haven't talked about radians yet. 4-degree measures. In order for you to find coterminal angles, you could add or subtract what amount of degrees? What do you guys think? If I'm doing a full revolution, 360 degrees. Okay? So let's go to part 4 here and let's practice. You have angle 36 degrees. I need you to find two coterminal angles. One that is positive and one that is negative to 36 degrees. Or that, whatever. Do me a favor, don't be that super smart person on the test and add like 8, 9 revolutions, please. Like, I get it, you know, you can find them. Don't make me check all that work. Cool? Just add 1 or subtract 1 revolution. Okay? Do we feel fairly comfortable with coterminal angles in degree mode? Alright, so then let's get to the good part, which is radians. Let's do this. Alright, so let's flip back to what we skipped. Alright. Measures of angles in trigonometry. Well, an angle is the amount of rotation from the initial side to the terminal side. We know that, right? We can measure angles in degrees or radians. We're familiar with degrees, now we're moving on to radians. Degree versus radian measure. This is a definition, and let's read it together to make sure that it makes sense. 1 radian is the measure of the central angle, theta, that intercepts an arc S equal in length to the radius r of the circle. Can anybody put that in everyday language? I thought so. So I got a little GIF or GIF, whatever you want to call them, for you to watch because it explains it to you. Okay? So I'm going to pause the video for the moment. Sorry if you're watching the video, you're not going to get to see this. Alright, so from the definition we learned that if this is your radius, a radian will be the same thing as the equivalent of that radius wrapped around. So that's 1 radian. Okay? And then I'm going to just approximate and just switch colors. That right there is 2 radians. 3 radians. And then when you make it to this, it's pi radians. Cool? Does that help you on your notes? Maybe do it, don't do it, it's your call. Okay? Alright. So now that we know that what a radian is, we're going to apply it. We know that a full revolution is 2 pi, correct? So here's what I want to do. We're going to draw ourselves another circle. Doesn't have to be perfect. And we're actually going to divide the circles in terms of fractions to help us out. What is the equivalent of 0 degrees as a radian? 0 degrees.
2 pi.
Almost. Subtract 2 pi. 0 degrees equals to 0 radians. Now, 360 degrees is equal to 2 pi. Very good. Are we cool with that? Alright, 0 degrees and in 360 is the same angle? No, they look the same. They are coterminal, but they're not the same. Good. Alright, now here's my question. Half of the circle is 180 degrees, correct? How many radians is that? Radians. Cool? Now, let's just focus on the top half of the circle. This is 90 degrees, correct? It basically split that half of the circle in a half, right? So if I have pi and I split it in half, what do I have? Pi over 2. Right? Now, I'm going to do the same thing but to the bottom of the circle. Do you guys agree that this technically is another pi over 2? But I'm not starting from, I'm starting here and I'm rotating counterclockwise. So would it be pi over 2? It would be what? 3 pi over 2. Which is the equivalent of how many degrees? 270. Cool? Alright. We can continue to do this and keep dividing and dividing and dividing, and you'll get exact angles every single time. Because notice how they're written. They're ratios. And ratios are going to be exact. Just a little heads up of where we're going. If you walked into the room this morning and you saw a circle divided into a whole bunch of things, that's where we're going, and you're going to have to memorize them. But that's next time. So for today, you can kind of breathe. I need you to at least know where these 4 are located for the moment. Can we do that? Cool? Alright. Let's flip the page. And because this is a brand new concept for you, and you're like, oh God, I still don't really get the whole concept of radians, there is a way that you can turn degrees into radians and radians to degrees, so you can have that little safe moment and like, oh, back to degrees. I think I can handle those, right? So I'm going to show you how to convert back and forth. The conversions are, if you have 1 degree, that is the same thing as saying pi over 180 radians. And if you have 1 radian, that's the same thing as saying 180 degrees over pi. Okay? So how would this work, or how can I use this? Well, we're going to skip this first one, and we're going to go to number 2, which says to convert the angles from degree to radians. So, my question to you is, if I have 60 degrees, how can I use what you just learned up here to turn 60 degrees into radians? What do we know? What do we know about 1 degree? 1 degree is equal to what? So if I don't have 1, I have 60 degrees, what would you do? Say it one more time. Multiply by 60. If I have 60 degrees, I'm going to multiply it to the equivalent of 1 degree, right? 1 degree is pi over 180, correct? So before I actually multiply, you should notice that this 60 and this 180 are going to do what? 60 goes into 180 how many times? 3. So this is a 1, and this becomes a 3. 1 times pi is pi over 3. 60 degrees is equivalent to pi over 3 radians. Can you turn the other ones into radians, please? Do that, and you should feel comfortable also converting radians to degrees. That time, instead of multiplying by pi over 180, you're going to multiply by 180 over pi for the bottom 3, correct? So go ahead and convert those 5 angles, and then we'll come back and check your answers. All right, if you're watching the video, check your answers. Now I want to talk about this last one right here, guys. Just because you see pi, it doesn't mean that it's in radians. Okay? Ultimately, you could plug this in the calculator and find out what approximately that would be as degrees. Like, I have no idea. So 540 over pi, I have no idea what that is. 540 divided by pi. So we're talking about approximately 171.89 degrees, right? Okay, so again, just because you see pi, don't assume that we're talking about radians. Which takes me to the next. I'm going to skip just to the bottom of the page. How am I going to be able to tell whether you're talking about radians versus degrees? If no unit of the angles are specified, that means the degree notation, I'm going to assume that you're talking about radians. So, for example, if you're trying to tell me 150 degrees, but you write that, I'm going to assume that you're saying this is 150 radians. You have to make sure that you use the degree symbols when you're trying to use degrees. Okay? I'm going to go easy on you at first, and I'll be like, okay, they forgot. On the test, I will take a point off every time you forget it. Cool? So they can add up. Alright. Takes me back then to coterminal angles one more time. Now that you know radians, you can find coterminal angles with radians. All you have to do to find coterminal angles in radians is add or subtract 2 pi, which is the same thing as adding or subtracting 360 degrees. Cool? So now you should be able to do part C and D. So find 2 coterminal angles in radians, one positive and one negative for both of those angles. Alright, if you're watching the video, please check your answers. So if you have a radius, here's your radius, that's your radius, and you have a central angle, so let's call it theta. You're going to intercept an arc, and let's call that arc S. So I'm intercepting this arc right here, and I'm going to call that S. Now, back in geometry, you learned a formula to figure out what that arc length was. Does anyone actually remember it? Alright, so let me ask you something. Do you remember how to find circumference? Alright, so I'm going to say arc length equals to 2 pi r, because that's the circumference. But do you have the entire circumference? You don't. You only have part of it. So you only have the ratio of the angle over 360. Do you guys remember that? So let's say that angle was 120, so then you would say 120 over 360. Because 120 over 360 is what, if you simplify it? A third. So would it make sense if I take the entire circumference and multiply by a third to get that? That's where this is coming from. This is going to be in degrees. However, this is why I like radians. Look at how simple the radian formula is. Arc length equals radius times the angle. But this has to be in radians. So your angle must be in radians for this formula to work. Okay? If you do not have radians, you can turn to radians and use this formula, or you can use the formula above. Okay? Example number 5. A circle has a radius of 27 inches, so radius equals 27. Find the length of the arc intercepted by the central angle of 160 degrees. So the angle is 160 degrees. Now, because I really like and I want to embrace these radians and move on to radians, right? I'm going to turn this into radians so I can start using them and get comfortable with it, right? So if I turn 160 into radians, how do you convert them? 160 times what? Pi over 180, right? So the zeros go away. 16 and 18, they're both divisible by. So that becomes an 8, and this becomes a. So 8 pi over 9. You guys see how you can avoid using a calculator? Awesome. Alright, so now you know that actually your angle is 8 pi over 9, correct? So, can you find the arc length? Yes, you can. S equals the radius times your arc length, times your angle, which in this case is 8 pi over 9. 27 times 8. What's 8 times 7? 56, and I got 5. 8 times 2 plus 5. And this is the arc length, right? What is the units? If you're measuring a length, there's different types of units, but for this problem we're using inches. Cool? Yes? Easy? Alright, awesome. You'll get to practice that on your homework, so let's move on. The last concept that I have for you is actually the area of a sector. So let's pretend you have an angle, and I'm looking for this area. That's what I'm talking about. Okay? Now, back in geometry, area of a sector worked very similar to the formula above, but instead of 2 pi r, it was pi r squared times your angle in degrees over 360. That's in degrees. But since we love radians so much, look at the formula. It actually, in my opinion, it's a lot simpler. 1/2 times the radius squared times your angle. Cool? But it has to be in radians in order for it to work. So look at example number 6. You have a sprinkler on a golf course. It is set to spray water over a distance of 75 feet. This is a huge sprinkler. It rotates through an angle of 135 degrees. So here's our sprinkler. Here's the radius of water. So that's going to be 75. And it rotates 135 degrees. So I'm going to say looks something like that, right? That's another 75. And then it just goes back and forth. You've seen those type of sprinklers, right? Cool. So it is forming a circular motion, agreed? Something like that. But the distance is always 75. Do you guys agree? Awesome. Can you find the area? I want you to find it in radians. I'll post the answer up here in just a second. You may use your calculators. The numbers get relatively large. But keep it in terms of pi, please. Okay? And that's really all I got for you. I'll post the answer here in just a second. After that, this is the homework for tonight. Alright, if you're watching the video, here's your answer. And that's your homework. See you next time.